Hello, everyone, and welcome to Semiconductor Pro in 3 minutes. Today's topic, the cruel trap of yield and chip area. Lately, you've probably been seeing news headlines like TSMC's next-generation 2-nanometer process is doing pretty well on yield. But that yield of N% number, taking it at face value, can actually be quite dangerous. So what is yield exactly? Semiconductors are manufactured by patterning many chips together onto a 30-centimeter wide, 300-millimeter wafer. After that, each individual chip gets electrically tested, and the percentage of working good die you end up with, that's what we call yield. Yield is critical because it directly drives cost. At the cutting-edge 2-nanometer node, a single 300-millimeter wafer is said to cost around $30,000. If you can get 1,000 chips from that wafer at 100% yield, each chip costs $30. But if yield drops to 60%, you only get 600 good ones, and each chip suddenly costs $50. That's exactly why foundries fight desperately to push yield up. But here, there's a huge hidden pitfall waiting. And that is, the meaning of yield changes completely depending on the size of the chip you're talking about. And now, today's pro tip. High yield on a small chip is a completely different world from yield on a giant chip. For example, even if a small chip shows a yield of 65 to 70%, a giant GPU with several times the area can, in a simple model, see its yield drop all the way down into the single digits. The reason is simple. The bigger the chip is, the higher the chance it will hit a defect somewhere during manufacturing. No matter how clean the factory is, defects can never be reduced all the way to zero. That's why bigger chips are always at a disadvantage. Here's the key point. The yield numbers you see in the news are often measured on smaller test chips or on relatively small area logic chips. So you can't just say 70% yield, we're safe. You really need to know what size of chip that number was actually measured on. Only then does the number truly start to mean something. AI GPUs in particular are absolutely massive. Even on the exact same process, the difficulty of getting good yield is completely different between a tiny smartphone chip and a giant GPU. Of course, in practice, there are clever tricks like disabling parts of the chip to rescue it, but even with all of that, the disadvantage of being huge never really goes away. In other words, when you see yield N% in the news, looking at the number alone tells you almost nothing. You also have to imagine the size of the chip behind it. That right there is the true Semiconductor Pro perspective. That's all for today's Yield Trap episode of Semiconductor Pro in 3 minutes. If you found this video interesting, please like, subscribe, and I'll see you in the next video.